Okay, in this video we're going to have a look at sketching parametric curves. Before we get on to that, I just wanted to touch on the problem that I set at the end of last video, which was to look at this parametric definition of a curve and to find the Cartesian equation of it. It is quite tricky, and I don't think this would be asked in an A-level paper. It is quite a messy set of algebra, but let's have a look at the solution now. So what I did was I first noticed that x as a function of t was a quadratic in t. So I made it a quadratic in t. And then what I did was I used the quadratic formula on that to make t the subject. It's not a function of x because it does have the plus minus in there, but I do have t in terms of x. Once I've got t in terms of x, I then just need to find t squared and t cubed and plug it into the definition up here. So what I did was I took this definition of t and I squared it, and that gave me this, which I simplified to that. And then finally I cubed t as well, which gave me ultimately this, and feel free to check that, but it is correct. I have checked it myself. Well done if you got that. It's not particularly pretty, but that is the solutions for t squared and t cubed. And then finally I used those two definitions into my definition of y to give me y in terms of x, and that gave me this mess, which I simplified to this slightly less messy mess. So that's the answer. So well done if you got that. Again, I have checked it. It is the correct answer, but that is hideous to look at, which hopefully will give you a bit of an appreciation as to why we use parametric definitions in the first place, because that is not easy to work with, whereas this most definitely is. Okay, the last thing I wanted to touch on was what range of values this is valid for. So what we can do is we can check what range of values x is for t values between -1 and 2. So if I draw a quick little sketch of x against t, there's my t-axis, there's my x-axis. It's a negative parabola, and it has roots at 0 and 1, so it's going to cross my t-axis there and there, which means by symmetry it's going to have its maximum point here at halfway between the two roots. When t is -1, we're going to get -3 times +2 is -6, so it's going to be down there. And when t is 2, again, it's symmetry. It's 1.5 away from the turning point, so 1.5 away. The other way is going to be the same value by the symmetry of the parabola. So it's going to go up as far as that and down as far as that. Now we know that's -6, and I know that that is a half, so I can calculate that by plugging in t as a half into here, and I get 3/2 times a half, which is 3/4. So the maximum value of x is 3/4, and the minimum value of x is -6. So I can say -6 is less than or equal to x is less than or equal to 3/4, and that's exactly how we should go about doing that. We do something similar for y. It's a cubic this time. It's a negative cubic. If I factorise out the t squared, I've got 2 minus t, so it's got a double root at the origin, and it's got a single root at t is 2. So when I come to sketch this curve, double root there, single root there. It's a negative cubic, so it's going to start high and end low, so it's going to have a turning point at the origin as well, and it's going to do something like that. So there's 2, there's 0. I'd have to use calculus to find what the value of the maximum is. If I plug in t as -1, I'll get 1 times 3, which is 3. So it's when it's -1, y is +3. And if you use calculus and find the value of the maximum does have a height of less than 3. So therefore y goes between 3 and 0. So I get 0 is less than or equal to y is less than or equal to 3. Okay, and I've completed that down here as well. So that really is part of the definition, because this is a full curve, but actually because t was restricted between -1 and 2 originally, then actually x and y are restricted as well. Okay, so let's have a look at how we go about sketching these. Now I'm going to check the answers with a graphical calculator. Now I'm fully aware you're allowed a graphical calculator in the exam, so if you have one, great, use it to sketch these curves to check your answer, or even to get your answer in the first place, but most of you won't have a graphical calculator, so I will go through how we go about doing it. So yeah, we're going to look at this example first of all. So what I recommend is we have a look at going back to kind of basic principles as to how we sketch curves, which if you think back to kind of key stage 3, key stage 4, you had these little tables of x and y, and then you just plotted the points and joined them up. We're going to do exactly the same here for parametrics. Okay, so I'm going to go into table mode on the calculator, which will make the process a lot easier, and I'm going to type in the function, so 3x, because it recognises a function of x. X is my variable, so 1 minus x. X is the variable on the calculator. T is the variable in my question. Okay, so just bear that in mind. The smaller calculators, the FX991s, you can plug in 2 functions as well, so you might as well plug in both of them at the same time. It saves having to do this twice for 2 different functions. So I've plugged in x as a function of t and y as a function of t. It just looks a little bit different on the calculator. And I'm going to start from -1, I'm going to finish at 2, and I'm going to go steps of 1. Okay. So I'm going to have 4 points. And if I click table, it gives me my table values. Also gives me the derivatives, but I'm not interested in those. So we can see that when t is -1, x is -6. When t is 0, x is 0, which, well, we knew that. Also, when t is 1, x is 0. We knew that because those were the 2 roots. And when t was 2, x is -6. Again, we knew that as well because of the symmetry of the curve. And the y values are over here in this column, y2. So when t was -1, y was 3. We knew that. When t is 0, y is 0. When t is 1, y is 1. And when t is 2, y is 0. Okay. So now we've got 4 points. Grab a bit of graph paper, pre-prepared. And we're going to have a look at plotting these points. So first of all, when t is -1, we got -6, 3. So -6, 3 is here. So that's when t equals -1. Then the origin, so it's down here. That's when t equals 0. Then we've got 1, but 1 is when x is 0, y is 1, so that's up here. So t equals 1. And then we've got t equals 2, we've got -6, 0, that's down here. T equals 2. Interesting. So what we've got is we've got something between there and there. Then we've got, it goes up here somehow, and then it comes down here somehow. Okay, we've not really got enough definition here. I don't know what's going on. So let's try and use a little bit more definition in the question to plot more points. So how we get more definition is we go back to our graphical or table mode, and I'm going to set this to go in steps of a half instead. So I'm going to have more points. So when I go into table mode, I've got not just -1, 0, 1, and 2, but I've got the ones in between as well. So I'm going to plot more points. So if I go back to a bigger table this time, I've already filled out the ones we've already done. And we're going to fill out the ones we haven't done. So when t is -1/2, x was -9/4, and y was 5/8. Then at a half, x is 3/4, which actually we knew that because that's the maximum value x is, and y was 3/8. And then at 1.5, x is -9/4, and y is 9/8. Okay, so that's going to give us more points to plot. So if we grab another piece of graph paper, which I appear to have lost. There it is. I can plot these points on here as well. So at t is -1, I'm here. When t is -1/2, I'm at -9/4 in the x, which is here. And I'm at 5/8 in the y. So that's about here. That's a half. So 5/8 is a little bit bigger than a half, so about here. So that's t is -1/2. And then this one here was t equals 0. And t equals 1/2, this was the biggest that x got. X was 3/4, y was 3/8, so just a little bit less than a half, so there. So that's t is 1/2. And then up here we got t is 1. And then when t is 3/2, we've got -9/4 again for x, but this time t is 5/8, is 9/8 this time. So that is up here. So that's t is 3/2. And then finally the point down here. So that gives us a bit more definition of the curve and what's going on. And we can join them up perhaps with a bit more of a smoother curve. Now, it will usually ask for a sketch of the curve, so it won't be on squared paper or graph paper. It doesn't need to be too accurate, but getting an idea of what these curves look like. Good. We know this is the maximum value of x, so it's going to be a vertical gradient at that point. And we'll look at differentiation of parametrics a bit later. It's going to have a positive gradient here because it's going to go through there. It's going to be quite shallow. And then through that point there. I don't know if that's a maximum or not. And then down to this, something like that. That's not a bad shape, is it? So that is the curve here. And if you still weren't sure with the definition that we've got, you can always include more points. The more points you include, the more accurate you can get your sketch. So on the graphical calculator, I can delete those. And if I go into equation mode, it looks like graph mode, I can sketch a parametric definition. So at the moment it's a Cartesian definition, y equals, but if I type, I've got Cartesian, polar, something in further maths, and then parametric definition. So if I plug parametric definition, it's got x of t and y of t. So I can plug those in. So the first one is 3t. Let's try that. I'm not sure if that... No, that's not going to be right. I'm going to plug in t. If it comes out wrong, it's fine. I can have a look at how to do that. And then 2t squared. Oops. 2t squared minus t cubed. Let's see if that draws it. If it doesn't, I might have to think about... Oh, there we go. It did draw it. That's good. I'm going to modify that. Oh, draw that. I'm going to modify the window. I'm going to change my theta values, which is the parameter. I'm going to go from -1 to 2. Okay, so that's my parameter, -1 to 2. And now if I draw that, and then I need to change the window, x goes from -6 to 1, and y, oops, y went from 0 to 3, there we go. So that's not a bad sketch, is it? There. It looks like it goes to the point -3, 1. It's not too far off. Okay, so that's how we sketch a curve. I've got one more example of how to of sketching a curve. So let's have a look at this one. Okay. So this one is a trigonometric one, but the principles are exactly the same. So if I exit this and go back into table mode, I'm going to define these. So I want y equals again. Y is a function of x. Will give me these two. So I'm in table mode and I'm completing this table up here. So what I'm going to do is I'm going to do sine of x times sine of x subtract 1. Making sure we're in radian mode. Okay, that's quite typical. The cosine of x, in fact, 0 and 2 pi, say radian mode. Cos of x times sine of x minus 1. Okay, set the values. I want to go between 0 and 2 pi, and I want to go in steps of pi on 4. And then this will give me a nice table of values which I can work with. So don't forget that this is my x value column and this is my y value column. So I'm going to fill out this table. Okay. So t is 0, x is 0, y is minus 1. T is pi on 4, x is minus 0.2, y is also minus 0.2. Pi on 2, I've got 0, 0, so it's at the origin at that point. 3 pi on 4, x is again at minus 0.2, and y is now at positive 0.2. At pi, x is 0, and y is 1. The next one, we've got 1.2 and 1.2. Oh, yeah. Yeah. And then we've got 2, 0. And then 1.2 minus 1.2. And then 0 minus 1. So that's all of my points there. And see, I've not been too accurate because I'm about to sketch the curve. So you don't have to be too accurate for these. Okay, so again, here's my axis, which I've already prepared. I'm going to plot the points. Let's fold this back so you can see the table as well. Okay, so when theta is 0, we've got x is 0, y is minus 1. So that's down here. And then it goes to minus 0.2, minus 0.2. That's about here. Then it goes to the origin. Then we've got x is minus 0.2, y is 0.2. So that's up here. And then x is 0, y is 1. So that's up here. Oh, sorry, that should be down there. That's not there. Apologies. Then we've got 1.2, 1.2. So 1.2, 1.2 is up there. And then x is 2, y is 0, so that's down there. And then 1.2 minus 1.2 is going to be there. And then we're back at 0 minus 1 again, so we're back there again. So it goes from here to 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 here and round. Okay, so we can join that up with a smooth curve. I do have a bit of an advantage that I know what this curve is. If you need more definition, then just make your table bigger, include more values. If you have a graphical calculator, then you can just use that. It's got a nice bit of symmetry to it, this curve, which you tend to get with curves with trigonometric functions. Ooh, that looked black because I pulled the black from it. It comes around there, into there, to there, back round to there. It's not too bad, is it? So we end up with this curve here. Now this is actually studied in further maths. This particular curve, it's called a cardioid, and they study it in polar equations. Okay, so the maximum value, you're going to have to differentiate these to get the maximum and minimum values of x and y. I don't think that's the minimum x value. I think it goes a little bit past it. I don't think that's the maximum y value or the minimum y value either. So yeah, you need to use calculus on these to find the maximum value of x and the maximum value of y for theta. In the range 0 to 2 pi. We can see the maximum value of x is 2 though. That is true. Okay, so that's sketching parametrics. Thanks for watching, and check out more parametric videos if you're I'm studying this topic right now. Thanks.